Hello, very good morning students. Last day we have started the chapter triangles. Not only that, in my last class I have discussed one of the most important theorem, the Thales theorem. And today from the chapter, the most important theorem, Pythagoras Theorem. Generally you will get it, they are giving in the board exam. So for board exam, the theorem is most important as a proof for mark question. Firstly, what is Pythagoras theorem? In a right angle triangle, from the statement, in a right angle triangle, the square of the hypotenuse always equal to the sum of the squares of other two sides containing the right angle. Try to clear. In right angle triangle ABC, already given angle A 90, that's why right angle triangle. Its hypotenuse, you know, opposite side BC of 90 degrees. So we have to prove hypotenuse squares means BC square equal to sum of the squares of other two sides containing the right angle. Containing right angle, other two sides AB square and AC square. This is the statement of the theorem. Now, for any proof you know from class 9 or from lower class, to prove a theorem, the different steps also we have done in the Thales theorem. What? First we have to write what are given. Already I said, in right triangle ABC, angle A is 90. After that, what is to prove? Already I said, the statement of Pythagoras theorem, or you have to prove in short, mathematically, AB square plus AC square equal to BC square. After that, the construction is what? AD perpendicular on BC is drawn. Our main proof part, look at the board. Before the main proof, one special calculation. After drawing this perpendicular line on BC, actually we are getting in the diagram the three right angle triangles. Follow, what are the three right angle triangles? Original triangle ABC, angle A was 90, that is right angle. After drawing the perpendicular, this side 90 because total 180, this side also 90. So triangle ADB is also right angle triangle. Triangle ADC is also right angle triangle. If I consider first the left side small right triangle, you see this angle 90. We know sum of three angles of a triangle always 180. So if I consider let this angle is x, sum of this two is 90 plus x, total angle 180. So third angle, this one will be 180 minus sum of this two is 90 minus x. Total value of angle A was 90. So 90 minus x, remaining part will be x. Similarly, for the third triangle, already we took this is x, this is 90, this one 90 minus x. So what we can draw the conclusion about the angles of the three triangles. What? All the three triangles, very very important. All the three triangles are equiangular. What is the meaning of equiangular? The three angles of all the three triangles are the same or equal. Now come back to the main proof. What? If I consider the out of three right angle triangles, first the which two triangles, triangle ABD and original triangle ABC. Already we said the three angles equal. So come back to these two triangles only. Angle B is common. Yeah, in the small triangle this is 90. In the larger triangle this is 90. So two angles are already equal. So the triangles must be similar. And we know, last day I discussed, what? When two triangles similar, the ratio of their corresponding sides must be equal. How to choose? How to select the sides? Also I said last day once more. You see, in the smallest right angle triangle, left side, in front of this 90 or opposite to this 90, the side is AB I took. its corresponding angle in the largest triangle is this angle A, its opposite side is BC. In front of or opposite of, in the small triangle, the side angle in front of this angle 90 minus x, the side is BD. Same angle, if the largest angle is this one, opposite of this one or in front of this one, the side is AB. By cross multiplication, we are getting AB square equal to BD into BC, equation number 1. Similarly, we are going to choose another pair of right angle triangles, the right small and the full right angle triangle, ADC and ABC. What are the angles? Compare. Already we said the two triangles are equiangular. Here is 90 in the smallest one. In the largest one, this is 90. Angle C is common for both. So both the triangles are similar. Again by the same property, what? Angle. Again take the ratio of the sides. In front of or opposite of 90 of the small triangle, the side is a C. Opposite of 90 of the larger triangle, the side is BC. That's why AC by BC we are getting. Similarly, you see, in or opposite to angle X, the side is DC, and here corresponding side is also AC. So by cross multiplication, we are getting what? AC square equal to DC into BC. It is equation number 2. So equation number 1 and equation number 2, if we add, means left side and right side both we are adding. Left side of equation number 1, AB square, here is also AC square, we are adding. Right side we are adding this result and this, but from both you see BC is common, so BD plus DC is coming. Now see, BC plus DC is actually which thing? BC plus BD plus DC is nothing but the side BC. So BC into BC, we are getting BC square. This is the proof of Pythagoras theorem. So what finally conclusion? Yes, in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of other two sides containing the right angle. That we have proved. So many application of this theorem we have to do from your book, exercise 6.5. Next day will be discussed. So today one more question I am going to discuss from the last exercise what I was discussing, exercise 6.3, and I told last day that 6.4 for this year is not in syllabus. The syllabus is already deleted. So come back to the application of last day. What the application we are doing? The similarity of triangles. One of the most important question from that exercise, and I said the application of Pythagoras will start next day. First you will learn the theorem very properly. You should practice. Now, what was the question? Say on a level ground, simply on a ground, there is a vertical pole. I am giving the name AB. Vertical in the sense the pole is making right angle with the ground. And say on the same base there is a vertical tower. I am taking the name like PQ. Now at a certain time, say the position of sun here, so the shadow will come on the opposite sides. For the pole, the shadow length I am going to consider BC. And not only that, in your book the value are also given. Height of the pole I am taking like 4 meter. Say this one is 8 meter. At the same time, for the tower, say for the tower the height is not given, I am taking H. But the length of the shadow made by the tower at the same time, say the length of the shadow I am taking R, QR. It is given, say it is 32 meter. Now, if I join this and the end point of the shadow and top of the pole, then I am getting a right angle triangle. Here also I am getting a right angle triangle. Now, both the right angle triangles we are getting at the same time, actually at that time the sun's altitude same, so these two angles are also equal. That's why both the triangles are similar, and when two triangles similar, you know what is the condition. Ratio of their corresponding sides must be equal, that I have discussed last day. So choose the side. First we'll write as the triangle ABC similar to triangle PQR. Therefore, ratio of the corresponding sides means AB by PQ must be equal to BC by QR. Substitute the given values. 4 by 8 meter, same unit cancel. Right side you are taking the height of the tower, say H, and QR is 32 meter. This is by calculation, but cancellation you are getting 1 by 2. So finally we are getting 2H equal to 32 meter. So H equal to 16 meter. So what is the conclusion? The height of the vertical tower must be equal to 16 meter. I think it is clear. And this type of sums also last day you have discussed from the exercise 6.3. This is one of the important sum from your book. This type of sum also you will get in the study material. Must practice those, all are important. And next day we will start what the application of Pythagoras theorem, what I discussed the proof today. So today is up to this. We'll practice the sum very properly. Okay.